Hello guys, welcome back. In the series of learning programming in C, in the previous video we have discussed about keywords and identifiers. In today's video, we will talk about data types. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notifications of all the new videos. Your support will give us more motivation and we can come up with more videos. So please do support us. Data types. Data is nothing but the raw facts. And types specify the type of data, the category of data, or what we call it as the type of data that what I am going to accept for my program. When I say data, the collection of raw facts, I can collect a variety of data. It may be numbers like 1, 2, 3 or 2.4. It may be whole number or it may be fractional number, or it can be characters or a character, a single character enclosed in single quotes, or the sequence of characters enclosed in double quotes. It can be a variety of data that what the user can provide for a program. But how the program is going to identify that and how it is going to decide how much amount of memory it has to allocate to store that data. So when I say in the memory, I'm trying to reserve some amount of space, then I should tell how much amount of space I need to reserve. For integer data, how much I need to store, how much memory I should require. So if it is a character, then how much memory? If it is a decimal point value, it is a sequence of characters, how I can decide the amount of memory that what I need to reserve in the memory. And that is what your data type is going to specify. So data type specifies the type of data that what the user has to give, and it also decides how much amount of memory it should allocate in the memory, how much amount of space it has to allocate in the memory. Say, and this storage capacity varies from processor to processor. For example, for 16-bit processor, it may be some other storage capacity. For 32-bit or 64-bit, it changes from processor to processor. So this is what the broad classification of the data type. So data type is classified into three types: basic or fundamental or primary data type. So under that we have word, integer, float, double and character. Derived data type, you have arrays, functions, pointers and reference. User defined data type, you have structure, union, enum and class. So let's talk about these three major types. Fundamental data type, the name itself tells you they are the basic data types, they are the primary data type. And using these primary data type, we define the fundamental set of values that what we are going to accept for the program, the basic type of values. It may be the integer numbers or it may be the fractional numbers, characters, like that. Whereas derived data type talks about, the name itself tells you derived, means it is derived from the existing data type. When I say array, array is a block of values of one particular type. It's a homogeneous collection of elements. When I say homogeneous collection, then I need to say what type of homogeneous collection, whether it's an integer collection of data, float collection of data or a character, means I am taking the help of this fundamental data type itself. So it is being derived from the existing. Or when I say function, I am creating a function that can return some integer value, that can take some integer value. So it is again taking the help of fundamental. So it is derived from the existing. Then we say pointers. What type of pointer? Integer pointer or float pointer? Like that. Then references. Well, all these topics are like individual chapters. We are going to discuss that in the next videos. Means we will have individual videos for these because all these are chapters that what we have to discuss in the future, right? Then you have the user defined. The name itself tells you the user is going to define a new data type. Say my fundamental data type can support only limited feature. I say derived, then it can say it is deriving from the existing data type again. But if I want to store a variety of data, so I just want to store the details of an entity. Say for example, I talk about this pen. I can have the size of the pen, color of the pen, brand of the pen. So every data that what I mentioned now, it is of different type. If I just say it is size, I say it is the integer data type or it may be a float data type. If I just say color of this, it is a character array. So I'm just mentioning different type of data, variety of data. So I need to have a data type that can support all these variety of data. Then I should create my own data type. So that is what user defined data type. So I can have a structure, I can have union, enum, class. So like this, you have the user defined data type. That is a data type designed by the user. Again, all these are individual topics that what we need to discuss the next coming videos and all. So let us talk about the first data type, which is the basic data type, or what we call it as primary data type or fundamental data type. So we have the first data type, which is void data type. And this void indicates that it is an empty data type. So it is an empty data type. We use this empty data type usually with functions just to represent that it is not returning any values. And we also use this void in the main also. So we say void main, saying that the main function is not returning any type of values. So it is empty data type. So then we have the next data type, fundamental data type, which is integer data type. So when I say integer data type, it says it is the data type that is which can accept integer type of values, the whole numbers. Every data type will have its own keyword, storage capacity, and format specifier. We'll talk about that. So integer says it can store whole numbers. Integer data type can store whole numbers. And the storage capacity varies from processor to processor. So if I use 16-bit, the storage capacity is different. 32-bit, 64-bit. So it depends upon the type of processor that what we use. Then the next one is the float data type. It says it can store fractional values. It can store fractional values. But can support limited amount of decimal places. So if I want to store a very big float number with more decimal places, then I have to go with one more data type, which is double data type. So double data type, again fractional numbers that can support more decimal places. More decimal places. How much it can store, we'll see to that later. Then we have character data type. So this character data type can store character values, characters, single character enclosed in single quotes. So these are the fundamental data types. So let's discuss about the storage capacity, the keyword used, and the format specifier of all these data types. So let's talk about the storage capacity, keyword, format specifier of all these fundamental data types. The first one, we have the integer data type, and the keyword used for that is int. The storage capacity is 2 bytes, and this storage capacity I am talking with respect to 16-bit processor. Then format specifier for this is percentage %d, and we use this format specifier with the input output statements to specify what format of data we are accepting from the user or what format of data we are going to display onto the screen. If it is float data type, the keyword is float itself. So all the keywords must be in lowercase. The storage capacity is 4 bytes. Again, I'm repeating, it is with respect to 16-bit processor. Then the format specifier is %f. Then we have double data type. Again, the keyword is double itself, but the storage capacity is 8 bytes because it can support more number of decimal places. And the format specifier is %lf, just to say it's long float. Then we have the character data type. The keyword is just char, char. It is just 1 byte because it can store a single character. And the format specifier is %c. So it's about the keyword, storage capacity and format specifier. So that's all for today's video. In the next video, we will discuss about modifiers and the range of data types. Till then, take care. Bye-bye.